Hi everyone, in the previous video, we have completed the pre-layout simulation of the NOR gate and now we are going to design layout, and after the completion of the layout design, I am going to check the results of layout design and comparison of both pre-layout and post-layout simulation results. So to design a layout, go to Launch, Layout Excel, and here the type and view should be layout. A window will be open here. Press on this window. For fit, press F. Go to connectivity, generate all from the source. I'm using chaining option to decrease some of the connections. I'm keeping the minimum separation as 0.12. I'm placing all the components in boundary. I'm keeping the IO pins as metal 1. Select apply. Come to generating. OK. In order to see the source and drains in a transistor, press Shift F. To increase the size of the boundary, select S. S defined as stretch. So move the boundary. For navigator, go to window, assistants, and navigator. Turn on your navigator here. Navigator will show the connections between ports. So first we want to create the substrate. To create for substrate, select the transistor and press Q. Go to parameter and select body type. Use detach. For PMOS, you should use top tap and select another transistor also. For NMOS, same procedure, but for NMOS we need to select on bottom tap. Now I'm going to connect it first the VDD connection. So to connect the VDD, first we want to connect this transistor to the substrate and then this pin to the substrate. So I need metal 1 and selecting metal 1 and zoom out. Use P for path. I'm making the path from this transistor to the substrate. So place the cursor in middle and press enter. Now one connection is completed and you want to connect this pin to the substrate. Press enter. See here VDD connection is completed. If any connection is completed, we get a wire symbol. Now I am going to connect VSS. For VSS, we need to connect these two substrate, and then after this VSS pin to the substrate. Now VSS connection also completed. Now I'm connecting port A. So here we need to connect poly to poly. So we need to select the poly layer. Select P for path. If we connect like this, then there will be a DRC error. We need to connect in this box only. So I'm making it. Enter here and again. Path. After that, we need to join this output pin to this poly. We cannot directly join the poly and metal, so we use via. Press O to get a wire and place the wire here and move this out pin and align the output pin to this white box. So use A, first select the reference one. First I am making the poly connection this side and then I'm making the metal connection. Now the port A connection is also completed. Now I am going to connect the port B. First we need to connect the poly and then we need to join this poly to the output pin. So first I am connecting the poly to poly using the poly layer. Next we need to join this pin to this poly. Directly we cannot join this, so we use via. I am aligning the pin to this box, white covered box. Now port B connection also is completed. One connection is remaining, output port connection. Take metal and press P for path, and we need to join. We need to join both this metal and connect to this metal pin. So no need of via. Now all the connections are completed. So then go to Assura and run DRC. Select OK. Press OK. So there is a error. Poly interactive poly spacing is not there. Here we got the error. So here the spacing between two polys are less. So we need to increase the spacing between these two polys. Now I'm going to delete this and this one also. I'm going to check the design rule check. So there are no errors. Next go to Assura and run LVS. So, okay. Yes. See here schematic and layout are matched. Press OK. Another window will open, schematic and layout match. Then again go to layout design and go to Assura and run RCX. See the technology must include as GPDK90 and the reference node as VSS. In filtering the power nets as VDD and VSS and ground net as VSS. So OK. Now RCX completed successfully. Now go to Virtuoso window and tools, library manager and select NOR KTB and create a new file and the type of the new file as config and press OK. Here keep the view as schematic and press use template and go and name as template name as Spectre and select OK. Here save and open. When you open, we will get the test bench of the NOR gate. Press F to fit and launch using ADEL. So go to analysis, keep the stop time as 200 nanoseconds, selecting as moderate and go to outputs to be plotted, select on schematic. First I am selecting input port, after them output ports and netlist and run. We'll get the results as this. And again go to config window. Now select the NOR gate schematic and give a right click, set cell view and place it as AV extracted view. Just save and again open. When we open, we get the same NOR gate test bench. So go to ADL window and change the replace option to append option. Netlist and run. We get two results. These are the pre-layout simulation results and these are the post-layout simulation results. So we need to check the parasitic difference between the post-layout simulation and pre-layout simulation. In order to check this, first of all I am changing the names. Go to select the net and give right click, select trace properties. This is a underscore sch. It means port A of schematic. This is port B of schematic. I'm changing the color also. Hello. Okay. I'm placing A on A and B on B and output as not on output. Zooming in. See, there is a parasitic difference between the post layout simulation and pre layout simulation.